Hi guys, so today we're gonna see relations and functions. This is the first chapter in class 12 math. So this is part 1, hence it's gonna be only relations. So majorly relations are majorly classified into 3 types. They are void relation, universal relation, and identity relation. Okay, so let's see what are these 3. First, void relation. So void relation can also be defined as a set which doesn't obey the given relation. It's a void set. I'll show you examples later. So what is a universal set? Universal set is something just opposite to void relation. So a set that obeys the given relation. Okay. So then what is identity relation? So identity relation is nothing but a set which has all the elements in it paired to each other is a identity relation. So let's come to examples. So for void relation, so let's take a set A is equal to 1, 2, 3, and I give a relation that A, B is to A minus B is equal to 4. A minus B is equal to 4 and A, B belongs to R. Okay, so this is my basic question. Let this be this question. Example 1. So first let's start at A cross A. A cross A is equal to 1, 1, 1, 2, 1, 3. Next, with this one, 2, 1, 2, 2, 2, 3, and with 3, 1, 3, 2, and 3, 3. Okay, so we have this relation. So we need to check if all these values satisfy this equation. So in all these sets, the first one will be A and the second element will be B. So the subtraction or the difference of these two values should give me 4. So since this is the largest element, I'll consider this one. So let's take this one first. Let's check with this. So let's take A is equal to 3 and B is equal to 3. So if you subtract A minus B, you are not getting 4. You will get 0. Am I correct? Let's take any other set. For example, let's take 2, 1 or 3, 1. A is equal to 3, B is equal to 1. Still, it will not be equal to 4. So any value from the set if you take, it won't satisfy this relation. So that is a void relation. Okay? So now, let me explain what is the universal relation. let's take the same set, and let's say for universal set, let's say that a plus b should always be greater than or equal to 4. Okay, so this is my, okay, let's take 2. So this is my relation. So we need to check if this satisfies the relation. So for the same set, okay, so let's take any value and check. So let's take this one. So a is equal to 1 and b is equal to 3 over here. So if you add a and b, you are getting 1 plus 3, that is 4. So 4 is greater than or equal to 2. Satisfies. Let's take any other. Let's take the first one itself. This is the smallest one, right? A is equal to 1, b is equal to 1. So 1 plus 1 is equal to 2, which is greater than or equal to 4, which is greater than 4. Am I correct? So for any element you check, this will be satisfied. So that is a universal relation. Let's check for identity relation. I'll take the same set, but let's say there's a relation like this. So this is my set. So if you see in the set, there are only 3 elements. So first one is 1, 1, second one is 2, 2, third one is 3, 3. If you see in the set, all these elements are there in set A. Am I right? 1 is there over here, 2 is also there, 3 is also there. So identity relation is a set which has all the elements paired to each other in the set. It must not be more than one or less than one. That means it must not contain extra elements or elements less than that. It must have exactly these elements. So this will be a identity relation. So next comes other relations: reflexive, symmetric, and transitive relation. So let's see what are those. Let's come to reflexive relations. So reflexive relations are those sets which contain an identity set and other elements or other sets also. So for an example, let's take this as example 1, and I'll take a set 1, 2, 3, and we get r is equal to 1, 1, 2, 2, 3, 3, 2, 1, 3, 2. Let this be the relation. Is this reflexive or not? So to check the relation if it's reflexive or not, check if this relation contains an identity relation. If you check these 3 ordered pairs, this is an identity relation. Am I right? Correct. So a relation which contains identity relation and other ordered pairs are nothing but reflexive relations. Okay, so these ordered pairs, it need not to be there, or it can be anything, but this identity relation is a must. Okay, so we can write it as a comma a belongs to R. So this is how we generalize reflexive relations, general equation for reflexive relations. Okay, let's see the symmetric equations. Okay, so if you see in symmetric relation, nothing. If there are two ordered pairs, let's say the first one, let's say if there is one order pair, let's say the first order pair is 1, 2. Then this order pair should be in the relation 1, 2, and it's reciprocal. That means it's symmetric. That means 2, 1 should also be present in this relation. Then it is said to be a symmetric relation. Okay, so if you actually see, an identity relation is also a symmetric relation, but a symmetric relation is not an identity relation. Understood? So this can be generalized by A, B. If A, B belongs to R, then B, A should also belong to R. Okay, so this is the basic general term for symmetric relation. Let's see transitive relation. Okay, so transitive relation is nothing, it's very simple. So let's take two ordered pairs. So let's say 1, 2 and 2, 3 are present in a relation. Okay. Now, to make this a transitive relation, I must have another order pair. Another order pair 1, 3. Let me explain why. So, if you take these both relations or ordered pairs, these both terms are same, right? Same terms. And these both are different. They can also be same, or they can also be same, but these two elements should be the same. Okay, they should not be different. These both should be the same. Okay, so in such case, the remaining two elements, sorry, not this, the remaining two elements should be parallel, and it should be